Hey everyone, welcome to Simplilearn's YouTube channel. Today we will learn SQL Data Analytics with MySQL Workbench. In this tutorial, we will be going through the fundamentals of SQL that will cover the basic clauses of SQL to the advanced clauses like joins, pattern matching, and much more. For better understanding of the importance of SQL, let's consider a simple use case for our real-time SQL sales analysis for business growth. So, the context. In today's business environment, making data-driven decisions is essential for growth. Imagine a car dealer keen to analyze sales performance and customer behavior to boost profitability. The dealer is eager to understand which fuel types, CNG, diesel, petrol, or hybrid, are most popular among customers. The owner needs data to guide inventory decisions and marketing strategies. This is where SQL becomes a game changer. The dealership database holds the wealth of information, and through SQL queries, the owner can extract detailed insights. Using SQL, the owner gets the number of cars sold segmented by fuel type. With SQL functions, they quickly generate a report showing which fuel types are in highest demand. Armed with this data, the dealership adjusts its marketing strategies, promotes high-demand vehicles, and aligns inventory with customer preferences. The SQL report streamlines the analysis and also forecasts future trends, guiding investment in electric and hybrid models as the market shifts towards sustainability. Now that we understood the importance of SQL in data analysis, let's proceed with a hands-on example. But before that, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Just for a quick info, if you want to upskill yourself, master data science and data analytics skills, and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various data science and data analytics programs. Simplilearn offers various certifications and postgraduate programs in collaboration with some of the world-leading universities like Caltech, IIT Kanpur, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like SQL, Advanced Excel, Python, machine learning, data visualization, generative AI, and over a dozen others. That's not all. You also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also academicians from top universities. After completing these courses, thousands of learners have transitioned into a data science or data analytics role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a data science and data analytics program that fits your experience and areas of interest. Now, without further delay, let's get started with our demonstration on SQL data analysis for today. So we will be having two different Excel files. So one Excel file will be having the customer's data set, and another Excel file will be having the dealership Excel file or dealership data set, right? And along with that, we will get started with the SQL Workbench, MySQL Workbench data tool to run our queries. I hope I made myself clear with that. Now let's get started. Now this is our customer data set. So our customer data set will be having order ID, state where the customer belongs to, and the region of that particular state, and his customer ID and his name, right? Along with that, we have another data set known as dealership data set, right? Remember this order ID, the first column, remember this, right? When we're performing joins, this is the key based on which we are going to perform the joins with two different data sets, right? Now let's check out the second data set. So this is our second data set known as the dealership data, right? So we are having the first order ID, and after that we have order date, delivery days, and dealership name, which particular store is that, and the dealership's PIN code, category of vehicle bought, and product name, quantity, fuel type, traffic, leads, orders, revenue, profit, and basically profit as revenue minus cost to company, right? And the order status, is it in transit, is the order cancelled or placed, or is the order delivered, right? So is it not delivered yet? So these are the order statuses. So we have four different of one of them: order in transit, delivered, cancelled, or not delivered, correct? So these are the two data sets that we will be working on today. And let's also take a look on the workbench that we will be executing the queries on. So this is the SQL or MySQL Workbench, where we will be executing our queries, right? So currently it is using data from a different data set, so we don't want that. We can create a new prompt and we can get started with our data sets here. So to get started with the new file, we might have to create a new schema first. So let's create a new schema. So you can just write down your name, car dealership, right? So that's the new schema name. Just apply. So you have just created a new schema. Now let's open the schema here, and you have the tables there, and you don't have any data table, right? So for that we might want to add a new table. So double click or right click on that, and here you can see a table import wizard. So browse the path, and here we have the dealership data. Open and click on next. And if you go back here, you have an option called drop data table if the table already exists, right? If you already have a dealership data table there, then you can just drop it off, right? And now let's try to make some changes to it because we don't want the confusion. So either what you can do is you can add an underscore, or if you want to keep the space, or you can eliminate that underscore. I'd prefer to eliminate that underscore and click on next. And there you have the data types, right? So if you want to change some data types, you can do that over here. And I think there is some issue with the first one. Here you have order ID with some extra thing which you don't want here, but we can clear that down the line, not a problem. And import the data file, click on next, and there you go. The data file should be shortly imported. It might take a little while, but it's all right. There you go. Click on next, and 1000 records have been successfully included. Finish. And we want another table also to be included. So what you can do is use the import data wizard once again and browse and import the customers data this time. Click on next, and the file name, just make sure that you don't have any spaces, but if you literally want the space, use an underscore but not the spacing, right? It might cause some problem while you're writing queries. That's the reason for which we should either eliminate or use an underscore. So go with next, and here we have the same order ID. No worries, we can change the column name over here, right? It's alright, just import the data, go ahead with it. Click on next and finish. 1000 records have been successfully imported. Now let's run some basic queries like okay, first we might have to use the dataset, right? So we want to use a car dealership. So car dealership, press enter, or you can use control enter. Okay, there was some spelling mistake. So I think we have created the schema with a wrong spelling, but it's okay. All we have to do is just change the name over here, car. So we have added an extra R there, but not a problem. So we are in the schema now. Now let's try to run. Okay, I'll not erase these names because we'll create a document out of it. So we can select any of the tables. Select, let's look at all the columns. Let's look at, okay, double click, start from, yeah, there you go. We have refreshed it. So if you extend, here you can see customer data, right? So let's type in customer data, semicolon, and there you go. When you run it, you have the data, right? So since we have 1000 rows, we can go with the current 1000 rows, or if you want to extend it, we can go with 50,000, or if you want the whole 1 lakh more than, right? There might be data with more than 50,000 rows. In those scenarios, you can also click on the don't limit option. But since we have 1000 rows, we can continue with what we have, 1000 rows, right? Now let's copy and paste the same command and change the name of customer data to dealership. So I'd like to pass a small suggestion here. So when you're writing the queries, use the keywords in caps, right? So uppercase and data tables or column names in lowercase, so that whenever you pass your queries or your document to your fellow developers, then they can easily identify the difference between the keywords and the column names or the data table names. This will help them to resolve an issue if there is, correct? So we have the table over here. Now, we have discussed some issue with the column name, right? Now we will proceed with a quick editing query where we will change the column name of this particular data set, or no, not just the column, correct? Just a moment. So we will take the help of alter keyword. So alter table, and our table name here is customer data. Before that, let's copy this particular keyword here, or we can do one thing, describe table. We can make use of describe keyword, describe table customer data, enter. Okay, let's find a way to at least copy that column name. I'm not finding how to copy that. Okay, we found a way. Right click or double click, and we have an option of copy field name. Let's copy the field name, and here let's continue with alter keyword, alter table customer data, and let's not use the semicolon here. Now use the rename keyword, rename column, paste the okay, alrighty. So there's the mistake. So we found a way to copy this column name. Just double click or right click here, copy the field name, so that you get the format or you get the exact data which is written as a column name here. There might be some mistake or there might be some problem during the import, but that's not something to worry about. So we are renaming the column name from the existing name to order ID which we want. So just place it over there, or you can manually write it so that you don't want to take any chances for any more risks. So order ID, there you go. Just run this query, and now let's select the data from customer ID once again, and there you go, you have a proper functional working ID. Now let's rename the order ID column from dealership data as well. So I want to rename customer data to dealership data. Just copy the name of the table and replace it over here. And yeah, let's check the columns first. There you go, you have a similar problem here. So let's change or alter the name of the first column in dealership data as well. Now quickly run the query, and now let's select the data from the dealership data. There you go. So we have a fully functioning or fully corrected data set. So we have order data. Remember, you can see I'm using underscore symbol here whenever or wherever I feel like having the space. You can eliminate the space and keep it as order ID in a continuous form without having a space or without having a underscore. But remember, don't just leave it as a simple space. If you leave it as a space, then you might be having deep trouble while you are writing a query to fetch some data. Okay, so SQL or MySQL Workbench might be confused to have spaces in between the column names or the entity names. Let's not make that happen, right? Now let's continue with some queries. So we are currently in the order or dealership data. So here we have some orders data. So we have a product quantity. Now let's build a a kind of a problem statement where we have to extract a couple of data sets or a couple of results from the data set that we have. Now let's make use of where statement and try to find some answers, right? Now let's say the dealer wants to know one of the dealership names where it is Prime Auto, right? So he wanted to know how many number of orders Prime Auto dealership has received. Now it's a simple where statement. Let's try to answer the query, answer the solution to the problem. Just write down, select. What do you want to select? I want to select the dealership name, right? Just write down, or let's use the auto suggest mode. So before that, select leave a space, from table name, which is dealership data. Right now you can proceed with the column names. What happens here is when I wrote select from dealership data, it is automatically giving me some recommendations here, right? So the typing time will be less, right? So I want to get back to dealership name, right? Dealership, press tab, and underscore name. I want this dealership name from dealership data, where dealership name is equals to single quote prime auto. And I also want to know total number of orders they received. So you can either use count or sum. I'll go with sum of orders. So far so good. So let's run this particular query. Control enter, and there you go. So we have found that Prime Auto dealership has received 5466 number of orders. So if you want to, if you don't want sum of orders here, you can also alias it by typing as total orders received. Yeah. So your column name has been successfully changed, right? And if you don't use alias as, it will still work. There you go. But in case if you want to make the code clearer to your fellow developers, I would recommend to use as, right? Now let's proceed with some other similar where commands so that you have a good habit of how to use where clause in your real-time queries. Now let's go back to our data and see what else we can build as a problem statement. So here we have days to deliver. Now let's say the client wants to know how many cars, if there is a premium, if it's a premium car, then he wants to know the premium cars which took more than 10 days for delivery. Now let's write a where query for that. Place the same query here, and now the name is where auto. I'll use an and statement here. Delivery date or days to deliver is greater than or equal to 10. Or we just copy this and paste it over here. And we don't want the alias. There you go. Now let's run this query. And why don't we also write the product name here, right? So we understand which is that car which is taking so much of time. So some of the cars are BMW X3 Baleno. So maybe some reason why these cars are taking a long time for delivery, right? So what happens here is he is able to understand there are couple of cars from couple of categories or couple of manufacturers which are taking a lot of time for delivering the car. So what he can do is he can write down a request or an email to those manufacturers to reduce the time they are taking to manufacture the product so that he can give an early delivery to his clients, right? Now let's run our query back again to see some more places where we can use the where clause. Right now let's see, we want to categorize or we want to find out specific cars from the segment sedan or the category sedan, where the dealership is Elite Automobiles and the fuel type is diesel, right? Let's try to build a where command for that. Let's copy the same where clause here, paste it again here, product, dealership name, and instead of days to deliver, let's type category. Instead of Prime Auto, we will be using Elite Automobiles. And the category is equals to, since we're using character data type, we will be using single quotes or double quotes, sedan. Control enter, and there you go. So Elite Automobiles is selecting or he is selling all the sedan class BMW series, and these are the details, right? So if the dealership wanted to know what are the cars or what are the products this particular dealership is selling in category sedan. He wants to know if he's focusing on any other manufacturer or a specific manufacturer, so that he wants to make sure that these type of cars or these type of makers should be proceeding with giving more deliveries of that particular category. Now this is one way of doing it, and now let's identify, since we have a couple of and a few more other categories, we want to find out the total number of orders received based on the category. Let's say the business owner wants to understand which type of category vehicles are being sold a lot, and he wants to make sure that his inventory has good number of such type of vehicles for future deliveries or future orders from the customers. In such situations, you want to group by the category, and group by is also a keyword in MySQL, where you can use that and categorize based on the category provided. Okay, let's build the query so that you can understand it in a better way. So let's copy paste the same query here, and now we will change a few terms here. Instead of product, we will write category, and instead of dealership name, and instead of category here again, okay, we will write down sum of orders from dealership data, group by category, and order by sum of orders descending. Now what does this query mean? It means I want to find out the category. So SUV category, sedan class category, and hatchback category, right? So I want to find out which type of category is getting the highest number of orders, right? In that case, what happens is, if you find out that SUV category is getting a lot of sales, then what you will do, you will buy a lot of SUV based vehicles from the manufacturers and keep them in your inventory, so that whenever you receive an order for that particular vehicle, you can show the options and make a sale, right? And why are we using order by, right? So we want to find out the highest number of sales, right? Order by descending, what it does is it keeps the highest selling category on top and the lowest selling category on the bottom. So if I run this query, you will understand what exactly I meant. So here you can see SUV category is the one which is receiving the highest number of orders, followed by hatchback, sedan, and multi-purpose vehicle, MPV, right? Now these are the vehicles. So what you will do is, the next business decision what you make is, you will try to order a couple of more SUVs for your inventory, and it can be from different manufacturers, and then you will provide multiple options when a candidate or when a client comes for buying SUV type vehicles. Now to deep dive, let's say, since you've already found out SUV is highest selling, and now you want to find out which is that one single car in SUV category which is getting those many high orders, right? So that you want to make sure that you want to understand this particular car is getting highest number of sales from SUV. So I want to keep a little bigger number of that particular car, so that whenever a client comes for that car, I have it ready, right? So if you make slight modifications to this query, you can come up with that category, and I'll also include product and sum of orders, and order by product, group by product, order by sum of orders descending. Now I am expecting a small error here, but it's all right. There you go. So we might have to place category as well. Okay. Let's try to run this query once again. There you go. So now we also might have to use a where command here, where category is equals to SUV. Now run the query. I guess you will find the answer. There you go. So BMW X3 series is that one SUV which is getting a lot of orders, right? Now if you scroll down, yeah, these are the top five SUV products for which we are receiving total number of highest order. So what we did here is we are selecting the category column, product column, and total number of orders, right? So we are filtering. Basically, we are using where command to filter down the data. So wherever the category is equals to SUV, filter those data alone. And now we are grouping by the product, which is here. Group by product and category, and order by sum of orders descending. Keep the highest orders on top and the lowest orders on the bottom section where the category is SUV. So in categories SUV, the lowest orders received are 1130 for BMW X5 series. So what you can do is, if you want to cut down, if your inventory is already having a couple of BMW X5 series cars, then what you can do is you can cut down the imports for that category. And if you have less number of X3 series, you can increase a couple of more cars, maybe 5 to 10 more cars, so that you have your inventory ready with X3 series for your clients, right? So this is how you can use where group by order by in your query. So let's say you wanted to eliminate that particular one product manufacturer which is receiving less number of orders in sedan class. So ASC ascending order, and it is sedan. Now if you run the query, you will find out sedan class BMW X3 is the one which is receiving less number of orders in the category sedan, and you can eliminate that. And if you want to specifically identify a particular dealership name which is having lowest sales, then you can also do that, where category is equals to sedan and dealership name underscore name is equals to Elite Motors, Elite Automobiles. You can also include the dealership name in the column here and group by category and dealership name, sum of orders sum of orders ascending, and run this query. And there is some problem here in the query. Dealership name category error, unknown dealership name in the field list. Okay, so Elite Automobiles. Let's copy this from here. So we might have made a spelling mistake in our query, but not a problem. Just place it here, and there you go. Now we must be getting the answer. Okay, dealership name. Okay, we messed out with the dealership name, so we had a spelling mistake in case of dealership name. Yeah, that's the one. And now let's run the query. There you go. So in Elite Automobiles in sedan class, we have BMW 5 Series in less number of orders received, right? Now, there might be some reason for it. Maybe the location of the dealership, where it is. So there might be chances, right? So where, let's say you are in South India, or let's say you're in North India, or some part of a country where the roads are really wonderful. You don't have a ghat section. You're not living in Western Ghats, and you're having good longer highways. In those segments of roads, you would prefer sedans. But in case if you are in a ghat section, or if you are in a where we have a lot of mountains, a lot of off-roading trekking kind of regions, in those regions you might prefer SUVs, correct? So there is a chance. Now Elite Motors might be in a place where there are some odd roads, not good roads. They might be a hilly region. It might be a region where you don't have good roads, right? Even if you're not in the Western Ghats or a Ghat region, or even if you're not in a region where you don't have any kind of hillies or mountain regions, but the roads are not good, or if you are passionate about it, it might be a trend, right? It might be some cult. If you are coming from a region where there's a good cult for SUVs, right? There might be multiple reasons. So I think that is one of the reasons why there could be a high demand for SUVs or sedans or a specific category of vehicles in a certain region. Now, let's proceed with the next remaining queries or clauses. So far, we have dealt with the with clause, the where clause, and order by, group by clauses. Now, let's proceed with case clause, right? Now, case is something like a switch case where you have, if you're familiar with the switch cases in programming, then case is similar to that in SQL. Now, let's say the dealer wants to identify or the business owner wants to identify different dealership names based on the profit they make, right? Or the number of the revenue they make. Then he wants to find out the highest profit making category as high profit, the medium profit, and the low profit. So the threshold is like 1 million. If they're making 1 million, then they are under highest category. If they are making in between 50 to 1 million, they're medium. And if they're making lower than that, then they are least profiting. And if they are least profiting, they might have to, the business owner might have to take some decisions, might be like helping them improve their sales, or fixing their contracts, or if they want to collaborate or combine that particular dealership, the high performing one, right? Some business decisions to make sure that everyone is breaking even in their profits. Now let's use the switch statement here. So as I discussed, high profit. So I'm going to take two columns here. So selecting the dealership name, sum of profit they are making, and case starts here. When sum of profit, I'm calculating the profit here, revenue minus the cost to company, is greater than 1 million rupees, that is 10 lakh rupees, then it is considered as high profit. And if the profit is between 50,000 or 5 lakhs or 1 million, then it is moderate profit, else low profit. Now, let's run this query, and we're grouping them by dealership. Let's run this query and see the output. There you go. So we have profit categories. Here we have high profit result. Okay, let's minimize this section here. Yeah, there you go. So there are 5 to 6 dealerships we have across the country, and most of them are in high profit, or all of them are in high profit. So if we increase the number to 10 million, so far we had 1 million. So if it is between 5 million to 10 million, now let's run the query and see if we have any. Yeah, so most of them are making good profits here. There you go. So far so good. Now this is how you can use a switch case statement. Now let's say I also want, okay, let's first use the pattern matching case here, kind of like statement we can use here, like clause. Now I want to make sure to identify a specific product. Okay, let's run this query once again, where we have the dealership data. Select all from dealership data. So now we have 8 series, X8 series, right? So some of the premium vehicles. Now I'd like to go with X8, BMW X8. So I want to identify the dealership names which are selling X8 series. Now we can write down the query as select dealership name. What you can do is just copy the dealership name so that we don't make any spelling mistakes. I think we wrote dealership. Yeah, we can remove this. Dealership name product from dealership data, where product like, or you can use like, I think we don't need to use equals to there, double quotes, mod, percentage or mod, X8 and percentage. Okay. So what am I specifically mentioning here is, I don't care if it is having anything in front of X8 and after X8. So we are damn sure that the series X8 will be released only by BMW. So in few scenarios, the BMW could be in small cases, or there might be no space in between BMW and X8, right? So I don't want to take a chance. So I want the exact details. So I don't care if there is a space or not, if there is anything else. There might be even spelling mistakes, BM or Beamer X8, or the full form of BMW, right? So, and after X8, I don't want to take any chances here as well. It might be series, it might be cars, right? So I want every detail, the dealership name and the product from the dealership data, who is having X8 car in their inventory. There you go. So we have so many dealerships here. So if I have to take the exact names, or if I don't want any repetitions, then I can go with the distinct here. So distinct of dealership names, where we can find out who is dealing with X8 in their inventory. So we have 5 automakers here, 5 dealerships who are having X8 in their inventory. Now let's also have a count, right? So we can make sure that how many number of X8s they have, count of product. So we can understand how many number of okay, so there is some query mistake here, aggregated without group by. So here we can add another statement, a group by dealership name or distinctive dealership. I'll just go with dealership name here, and order by count of product descending. Now let's try to run this query by product. Now let's run the query. There you go. So we have City Motors, who has the highest count of BMW X8 series, and they have the biggest inventory, I presume. So in the next upcoming fiscal year, if there is a requirement of importing X8, then you can check out the numbers, right? If you want to import a huge inventory, or if you want to reduce the number. And you can also, if there is a good sale for Asian dealership for BMW X8 series, you can also improvise their numbers as well. So that's how you can use the pattern matching statement. And if you don't want, if you want to exclude X8, then what you can do is just place an I here, I like, or product not like X8. So if you're filtering out X8 and running numbers or codes for everything every other car but X8, you just want to run that query, and here you can see instead of X8 you can have details repeat, and you can see instead of X8 you have every other detail on every other car. That's how you can go with it. Now let's proceed with joins in our tutorial for today. Now let's create a use case, right? You wanted to identify all the customers who bought an X8, right? So if you check the data, if we go back to our query here and run the dealership query, and you can see here we have order ID, order date, delivery date, everything. But we don't have customer name, but I want the customer name. But customer name is in the table customer data, right? And here we don't have the product detail what they bought, right? So Vivan Sai or Vihan Arab, it can be anyone who got an X5 or X8, right? But now I want to know the exact customers who are or who have already placed an order for X8, or you've already delivered that X8, right? Or let's say you wanted to know if they have placed an order for X8. Now in this situation, you might want to make use of joins, which join two tables and give you the results. So there are basically a couple of joins that you can use: left join, right join, inner join, outer join, Cartesian join, right? So most of the cases you would just go with the keyword join. So it will basically function like a left join, right? You're choosing the first table and you are choosing the matching data from the right table. Now we want the order ID column, we want the customer name, and also the product name, which is equals to X8, and we want to run a join command based on order ID. So order ID happens to be the primary key based on which you can perform the join. So it could be a little complicated orally, so I will write the query so that you have a better understanding for it. So let's quickly run the query. I'm going to use the select statement here, and we wanted the customer name, right? So we want the customer name, or we have it here, right? Double click, copy the field name so that we don't have any mistakes done, and it is from customer data, right? So customer data dot customer name. Okay, let's also copy the customer data table name as well, right? So that we don't have any mistakes in our query. And want dealership data table name as well, so comma dealership data, and what we want from dealership data is product, and we also want dealership data dot order ID, copy the field name, comma, from dealership data, join customer data to dealership data on what terms. So order ID is common between customer data and order data, right? So we want order ID equals to order ID, but it will be confusing. So what we can do is join customer data on customer data dot order ID and dealership data dot order ID, right? And we will also use a where clause where product dealership dot product, like again the same statement which is here. There you go. Now we are selecting order ID from dealership data, customer name from customer data, and product name from dealership data from the table dealership data. Join customer data table on customer data dot ID is equals to dealership data dot ID, which is the order ID, where dealership data dot product, right? The product details are in dealership data table, and the product is like anything before X8, anything after X8. Because we want the details only for X8, the customers who bought X8. Right, now let's run this query, and there you go. So these are the customers who bought X8s. So we have about 29 results. 29 members are the premium customers who got this premium vehicle X8 series. Now that's how you can use joins in a SQL table, a SQL data query. And so far we have covered joins, we have covered case, we have covered pattern matching, we have covered where clause, group by, order by, and select, and few others. So we have also made a complete documentation out of it. We now know how to create a schema, how to import data, and few protocols to follow when you're importing data, like using an underscore. And we also have covered alter table if you have some mistakes in your column name, how to alter the name of that column, right? So these are the fundamentals that you can know about SQL, and also some advanced concepts like case and joins that you can know about SQL. So so far we have covered everything that you must know for a beginner, and also we have covered something if you're an advanced level SQL developer. It's like a brushing up tutorial for you, how to use some clauses like group by, order by, and how to use cases, how to use joins, right? And that calls for the end of this tutorial on SQL data analysis. And if you have any queries regarding any of the topics covered in this session, or if you require the datasets or any of the resources that we used in this session, like datasets, the document where we have created all the queries, then please feel free to let us know in the comment section below, and our team of experts will be happy to resolve all your queries at the earliest. Until next time, thank you for watching, and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.